Hello, fellow makers and aspiring inventors. Today, we're diving into a world where we can build things without actually building them. Confused? Don't be. I'm talking about two of my favorite tools, Arduino and Proteus. Arduino is like a tiny friendly computer brain. You can tell it what to do, and it controls things like lights, motors, and all sorts of sensors. It's the heart of many of my questionable robots and wonderful contraptions. It's super easy to get started with, which is great because sometimes my ideas are complicated enough without the electronics trying to be difficult too. It's the reason I can make a robot that brushes my teeth, or a machine that chops vegetables with questionable accuracy. Now let's talk about Proteus. Imagine you have a giant magical drawing board. On this board, you can draw an entire electronic circuit, complete with all the wires and components, and then with a click of a button, it comes to life. That's Proteus. It's a piece of software that lets you design and simulate electronic circuits on your computer. You can build your entire project in this virtual world before you even touch a real wire or a soldering iron. This is incredibly useful, especially for someone like me whose initial designs sometimes have a tendency to, let's say, not work perfectly on the first, second, or even third try. So we have Arduino, the brain of our operation, and Proteus, the virtual playground where our brain can run wild without any real-world consequences. Think of it like a video game for electronics enthusiasts. You can pick your hero, the Arduino, give it some cool gear like sensors and other parts, and send it on a quest, running your code, all within the safe, cozy confines of your computer screen. You don't need a massive workshop or a huge box of components to start inventing. All you need is your computer, some ideas, and a little bit of curiosity. It's the perfect setup for late-night inventing sessions. Putting these two together is where the real magic happens. By using Arduino inside of Proteus, you can build and test a complete project, from the physical wiring to the software code, all in one place. You can see how your temperature sensor will react to virtual heat, or how your light sensor will respond to a virtual flashlight. It's like having a crystal ball for your electronics projects. This combination has saved me from countless headaches and probably a few small accidental fires. It's the ultimate way to bring your ideas to life, one virtual component at a time, before you unleash them upon the real world. So why bother with all this virtual stuff? Why not just jump right in and start connecting real wires? Well, let me tell you, as a professional builder of less than perfect robots, faking it before you make it has some serious perks. First and foremost, it saves you from the "oops, I fried it" moment. Electronic components can be delicate little things. If you connect a wire to the wrong pin or use the wrong resistor, you can easily send your precious Arduino or sensor to the great electronics workshop in the sky. In Proteus, if you make a mistake, you don't get a puff of smoke, you just get an error message. It's much cheaper and less smelly. Another huge benefit is that it saves a ton of time and frustration. Imagine spending hours carefully soldering a complex circuit, only to find out that your design was flawed from the very beginning. It's heartbreaking. With simulation, you can build, test, and rebuild your circuit dozens of times in the span of an afternoon. You can quickly identify problems in your logic or wiring without having to painstakingly troubleshoot a physical mess of wires. This lets you focus on the creative part of your project, the "what if I made a robot that applies lipstick" part, instead of the tedious "which of these 50 wires is in the wrong place" part. Simulation also opens up a world of possibilities that might be too expensive or difficult to test in real life. Want to see how your circuit would behave in extreme temperatures? In Proteus, you can just dial up the virtual heat on your temperature sensor. No need to stick your project in an oven, which I definitely do not recommend. Want to test a sensor that you don't own yet? You can just add the virtual version to your Proteus schematic and see if it's the right fit for your project before you spend any money. It's like a try before you buy for electronic components, which is every maker's dream come true. Finally, it's an incredible learning tool. When you're just starting out, it can be really intimidating to work with real hardware. The fear of breaking something can hold you back from experimenting. Proteus removes that fear. You can try out the craziest ideas without any risk. You can poke and prod at your virtual circuit, see how different components interact, and watch the signals flow through the wires. It gives you a deep, intuitive understanding of how electronics work, building your confidence until you're ready to take on the real world with your soldering iron held high. It's a safe space to fail, and failing is just another word for learning. Alright, enough talk, let's get our hands virtually dirty. The first thing you need to do is get your Arduino ready for its Proteus debut. Now, Proteus doesn't come with Arduino boards built in right out of the box. You have to add them, which sounds complicated but is actually pretty easy. You'll need to find an Arduino library for Proteus online. A quick search will give you lots of options. These libraries are basically little files that tell Proteus what an Arduino is and how it works. Think of it as giving Proteus a user manual for your Arduino board. Once you've downloaded the library files, which usually come in a zipped folder, you need to place them in the correct Proteus directory. This is usually a folder called Library inside your main Proteus installation folder. You just copy and paste the files into that folder. It's like putting a new book on a library shelf so the librarian Proteus knows where to find it. After you've done that, restart Proteus. When you open it up and go to the component library to pick a part, you should now be able to search for Arduino and see familiar boards like the Arduino Uno pop up. It's a magical moment. With your Arduino board now available, you can start building your schematic. Think of the main window in Proteus as your virtual workbench. You can select the Arduino Uno from the component list and place it right in the middle of your workspace. This will be the brain of your project. The next step is to add a sensor. Let's say we want to build a simple project that measures light. We'll need a light-dependent resistor, or LDR. Just like you did for the Arduino, you'll go to the component library, search for LDR, and pick one that looks good. Place it on your schematic near the Arduino. Now we need to connect them. This is the virtual equivalent of using jumper wires. In Proteus, you simply click on a pin on the LDR and drag a line to a pin on the Arduino. For our LDR, we'll need to create a simple voltage divider circuit. This means we'll also need a resistor. So back to the library we go to grab a standard resistor. We connect one leg of the LDR to the 5-volt power pin on the Arduino, the other leg to our resistor, and also to an analog input pin like a 0 on the Arduino. The other end of the resistor gets connected to the ground pin. It's just like connecting dots, but instead of a picture, you get a working circuit. So we have our hardware all wired up in our virtual world, but a brain without thoughts is just, well, it's just a circuit board. We need to give our Arduino some instructions. This is where the code comes in. The great thing is that you write the code just like you normally would using the official Arduino IDE. So you'll open up the Arduino software and write a simple sketch. For our light sensor project, the code would read the analog value from pin A0, which tells us how much light the LDR is seeing, and then maybe print that value to the serial monitor so we can see it. Once you've written your code in the Arduino IDE, you need to get it into a format that Proteus can understand. You don't upload it to a physical board. Instead, you need to export a special file called a hex file. In the Arduino IDE, you can go to the sketch menu and select Export Compiled Binary. This will save a hex file in the same folder as your Arduino sketch. This file is the compiled version of your code, the pure machine language that the virtual Arduino in Proteus will execute. It's like translating your instructions from English into the Arduino's native tongue. Now back in Proteus, you need to load this hex file onto your virtual Arduino. It's super simple. You just double-click on the Arduino board in your schematic. A properties window will pop up. In that window, you'll see a field called Program File. You click the little folder icon next to it and navigate to where you saved your hex file. Select it, click OK, and that's it. You've just uploaded your code to your virtual Arduino. It's so much faster than waiting for a real board to upload, and you can't accidentally pull out the USB cable midway through. Finally, the moment of truth. At the bottom of the Proteus window, there is a play button. Clicking this starts the simulation. Your virtual circuit will come to life. To see the results from our light sensor, we need to open the virtual terminal in Proteus, which acts just like the Arduino serial monitor. As the simulation runs, you should see the light level values being printed out. The best part is that you can interact with the sensor. The LDR component in Proteus will have a little toggle or slider next to it. By changing it, you can simulate more or less light falling on the sensor, and you will see the values in the virtual terminal change in real time. It's an amazing and powerful way to test and debug everything safely from your desk.